right, guys, for today, this is the section that most people, if you're going to struggle in this chapter, this is where it's going to be. Because we are adding and subtracting. Now, my big kind of joke to you guys this whole chapter is read your paper, right? You need to read your paper on this section. Don't think you know what's going on unless you are really wonderful at fractions, like just normal fractions, because it's different than multiplying and dividing. Multiplying and dividing, I mean, you can cancel stuff, like it's, not so bad. This is not the same, okay? So let's kind of start basic. Let's go old school. So what is 2 sevenths plus 3 sevenths? 5 sevenths. Now, so let's kind of stop and talk for a minute, because we got to start basic, because then before we start throwing x's and all that other stuff in there. So when you add or subtract fractions, what happens to the denominator? It stays the same. You don't actually add them together, okay? And it has to be the same in order to put them together. So 11 fifteenths minus 1 15th, 10 fifteenths. Good. After you would subtract, then you would simplify, which would be 2/3. Okay, what about 3/4 plus 5/14? The denominator has to be the same. Does anybody know what the denominator needs to be? Good, it needs to be 28. So trying to get them to be the same, some people are really great at just looking at it and they can just tell what it's supposed to be. Other people stink at that. I'm sorry. I mean, I need to be able to multiply them both by something so that I get them to be the same. And 28 just happens to be the number I can multiply to get them to be. Can I make them smaller? Because every year someone, when I say this, they're like, 2. Can I turn them both into a 2? No, I can't. Okay, they have to be at least as big as the biggest one, if not bigger, right? I can never make them smaller. I need you to get that through your heads. We cannot make them smaller. So how do you turn 4 into a 28? Times it by 7. So if you multiply the bottom by 7, you also multiply the top by 7, which gives me 21. What do you multiply 14 to get 28? If I multiply the bottom by 2, I also multiply the top by 2. And that gives me 10. So now 21 28ths plus 10 28ths, 31 28ths. Does that simplify it all? No. I know it's improper, but I don't care. Improper is fine. Okay, so try to keep that example in mind as we kind of get going through all this. So 7 over 4x plus 3 over 4x is 10 over 4x. Right? I mean, just looking at a very basic, the denominator is already the same, stays the same, and you just add at the tops, right? Oh, I remember if it's not held with a plus or minus, I can break that apart, right? Yeah, so I can break that apart. So I can divide them both by 2, and I get 5 over 2x. What are your restrictions? X cannot equal 0. All right? 2x over x plus 6 minus 5 over x plus 6. Ooh, very nice. The common denominator is x plus 6. And so then on the top, 2x minus 5 is 2x minus 5. So do you guys see now it's just one fraction, right? So what's your restrictions? All right, x cannot be negative 6. Can I factor either of those? So does anything cancel? Oh, and I am done. The most common mistake I see is people turn that top into like negative 3x, or they turn it into like 10x. Like they don't actually do the right math with it. Okay, they're not like terms. I can't actually do anything with them. All right, so those are the easy ones, right? Denominators are already the same. I can just kind of put them together. So the hard part is finding that common denominator. Whew, so here's your steps. This is step by step how to do the whole process. So step 1 is to factor denominators. Before it just said factor, and I factored everything and anything I could. But since this one just says factor denominators, I'm only going to factor what? The denominators. Are you factoring the numerator here? No. Jasiri, are you factoring the numerator? No. Okay. Step 2, find the LCD. What does that stand for? Good. The least common denominator. This is where people will struggle. They struggle figuring out what that is. But keep in mind, can I make them smaller? No. It has to be at least that big, if not bigger. Okay? Then you will multiply each fraction by the missing piece to obtain a common denominator. So what I mean by that missing piece is like here. What did you multiply 4 to get 28? Well, you multiplied it by 7. 7 was the missing piece. It's what was not there. Whatever you do to the bottom, you also do to the top. You all right, Robert? Okay. All right, then you will add your numerators, right? Because once they're common, then you're going to go ahead and add those numerators together. Then you'll do your restrictions. Then you'll factor the numerator. Cool. So I factored denominator way at the very beginning. It's still factored all the way through this. But I don't do the numerator until step 6. Because I had to put them together before I could look and see if I could factor it. Then, last, cancel. So should I, like, as I'm working through this, be like, oh, I can cancel something right here? No. Canceling's last. If you were canceling and you were not done, you were not canceling in the right spot. Okay? All right. Let's just jump right in. Okay? Yes. So, step 1, factor denominators. Do either of those factor? Yes, the second one does. What can I factor from here? 3x. So we have x plus 1. So that was step 1, factor denominator only. Do not even look at the numerators. Step 2, find the LCD, my least common denominator. Here's the trickiest part of all of this. So I need to turn those both into something that's the same. So it cannot be smaller. It can only be at least as big, if not bigger, right? So I have some like random pieces that aren't held with a plus or minus, right? So between 9 and 3, what can I turn those both into? A 9. Between x squared and x? I can't make them smaller, right? So it has to be at least x squared. I can't make that one any smaller. All right, and then what about the x plus 1? I need an x plus 1. Right, those pieces held with a plus or minus, they're attached. I can't break those apart. So I'm going to need the 9, the x squared, and the x plus 1. And again, we'll get lots of practice with these numerators or denominators. That's the hard part. All right, so then step 3, multiply by the missing piece. So what is this denominator missing to look like this? It's missing the x plus 1. It already has the 9, it has the x squared. It doesn't have an x plus 1. Right, so if I would do the bottom by x plus 1, now it looks the same, right? If I multiply the bottom, I also multiply the top. Now, do you notice your step-by-step actually says multiply? It didn't say smoosh. So you actually multiply this. That's going to give you 7x plus 7. Okay, what about the other one? What is this denominator need to look like this one? How do you multiply 9 to get, or 3 to get 9? I have to multiply by 3. How do you multiply x to get x squared? I need another x. And then I already have the x plus 1. So if I would multiply that, I'd get what I wanted, right? So that means I also have to multiply the top by 3x. What's x times 3x? And you guys see the big plus sign in the middle? So plus 3x squared. Doing okay so far? Stop me at any point if you're just like, what did she just do? I know it's hard. We'll do a lot of examples today. All right, so step 4 then is to add my numerators. Do I have any like terms? No, but do you like the order? No. Let's rewrite it so it's in the right order. So 3x squared plus 7x plus 7 over 9x squared and x plus 1. Okay, so I couldn't add anything. Step 5 is my restrictions. What is x not allowed to equal? 0 and -1. Restrictions are still coming from denominator only. Step 6, factor numerator. Is that going to factor? It doesn't factor. It looks like it should, right? It's got like the 3 terms. It's set up just like we like them. But if you play with the numbers, it actually, does not factor. And then step 7, does anything cancel? Can I cancel the 3x squared with this 9x squared? I cannot. You see how that's added? It's attached to the plus sign, so I can't touch that. So this is as simplified as I can get it. Sometimes you add them together and then like all kinds of things cancel and it's a beautiful result. Sometimes they don't. And that's when kids get frustrated because they think it should factor. They don't always. Questions so far? Let's do more. All right. So x over x squared minus 4 plus 1 over x plus 2. So step 1, factor denominator. Either of those factor? My favorite. Right? This one's x plus 2, x minus 2. I didn't skip a problem, did I? Oh, I did skip 7. Ha. Sorry. Oh, sorry, I didn't realize it skipped when I clicked the next button. Sorry to throw you guys. I heard you flipping papers. I'm like, wait, you guys look confused. Sorry. We'll go back to 7. Step 1, factor denominators. Either factor? Yeah, that second one does. How's that one factor? Good. X minus 1 and x minus 2. Are you starting to see why I was like, if you like to factor and are good at it, it's not so bad, right? Because we factor a lot in this chapter. All right, step 2, find your LCD. Take a minute. Don't say anything. Just write down, even if it's off to the side, what you think the LCD is. Just take a second and write down what you think it should be. All right, so I need it to be common. So what do I need? You heard x minus 2, x minus 1. Anything else, or is that it? That's it. So I needed like one of each, right? Now the only time, like some people want to put an x minus 1 on there twice. The only time I would need it twice is if one of these had it twice. Because remember, I said I can't make them smaller. But I can keep it the same size it is, or I can make it bigger. So what is this fraction, what is that denominator missing to look like this? An x minus 2. Now it looks like it's supposed to. So if I multiply the bottom, I have to multiply the top. And don't smoosh, actually multiply. So when I multiply this, I'm going to get x squared minus 2x. Bless you. Okay, next fraction. What is this denominator missing to look like this? Nothing. So what do I do with the top? I just bring it down. Yeah, plus 2x minus 1. It didn't need anything. It already had all the pieces. But you see how now if you look, your denominators, they're both the same. So I can actually kind of put them together now. So step 4, add numerators. Anything I can put together? Good. My negative 2x and 2x, let's cancel. So I have x squared minus 1 over x minus 2, x minus 1. That was step 4. Step 5, restrictions. X cannot equal what? 2 or 1. Again, those are coming from my denominator. Step 6, does the numerator factor? That's x plus 1, x minus 1. And then the last step, does anything cancel? Yes, the x minus 1's cancel. So it's going to be x plus 1 over x minus 2. Ooh, can I cancel the x's? No. How about the plus or minus? Can't touch them. How we doing? You guys are really quiet. Danny? Yes. If they were both pluses, yes. If as long as they're exactly the same, then wait, let me make sure I'm answering the right thing. Hi. You did during D block. All right, Danny, ask me again what your question was. No. No. Okay, I thought maybe I misunderstood your question. The only way it would cancel if they were both like x plus 1's exactly the same on top and bottom, then they would cancel out. But x plus 1 and x plus 2, they're still not exactly the same thing. Anytime it's attached to the plus or minus, you either cancel the entire piece out or nothing. Okay? 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 Okay. All right, let's come back to 8 now, since we already factored that denominator. All right, are we ready? Do you guys want to try this one on your own yet? Let me give you a few minutes. Do what you can. If you get lost, that's okay. But let's just try it. All right, so what is the common denominator? I think we, for the most part, seemed okay there. Good, x plus 2 and x minus 2. Right, I need an x plus 2, I need an x minus 2. That accounts for everything here. And that one had an x plus 2. I already wrote that down. So I can make it look like this, right? So what is this missing to look like this? Nothing. So just an x is going to come down. Okay, what is this missing to look like this? It's missing the x minus 2. So then we're going to multiply the top by x minus 2. And if I distribute a 1 to that, I just get x minus 2. Now, some of you lost this. See the plus sign in between there? And then it's x minus 2. Some of you wanted to multiply those together again. Okay, there's a plus sign in between there. All right, so now we're at add numerators. What's x plus x? If you have one cookie and I give you another cookie, how many do you have? My cookies are not square because I have 2 of them. That would be 2x. Adding them together, that's what I always think about. When you're adding something, like just picture like just adding it into a pile. Does it change the shape of them? They don't turn square, okay? You just add more of them, right? And then minus 2 over x plus 2, x minus 2. All right, that was step 4. Step 5, restrictions. X cannot equal, good, plus or minus 2, coming from your denominators. Step 6, factor the numerator. Yes. Yes, I could take out a 2. I'm left with x minus 1. You guys need to really look for that LCD in there, or the GCF, not LCD. Okay, GCFs are hiding in there almost all the time. You can always pull those out. And then step 7, does anything cancel out? No, there's nothing to cancel. So my simplified answer is 2 times x minus 1 over x plus 2, x minus 2. Yeah. Wait, from this step to this step? I just factored. I was at the factor my numerator step. There was a GCF sitting in here. I can divide them both by 2. Other questions, guys? Did anybody get it right? A couple of you? Couple? Okay. Guys, it's okay. We're going to spend today and tomorrow on this. So we're not going to just fly through this and not think long and hard on it, okay? We're going to spend 2 days just kind of getting through the notes on this. All right, number 9. Step 1, factor denominator. Do you want to do it yourself again? You want a chance to redeem yourself? So we'll go through this one together. I'll give you a chance again in a minute. Yes. Guys, on this one, you have a GCF of x. So I have x minus 1 left over. It will give you a minute to think about what the common denominator is. Stop and think for a minute what the common denominator is, because that's usually where people get tripped up, is knowing what that is. So Carson, what do you think? What's my common denominator? I need an x, and I need an x minus 1. That one has both. I have to have at least that. Can I multiply this one to turn it into that? Yeah, it's just going to miss one thing of it. But you have to look at each denominator knowing I can't make them smaller. So I have to have at least everything that's in the bottoms, right? And I kind of look and see what I still need for other ones. That's the trickiest part. All right, so what is this denominator missing to look like this? An x. So that means I have to multiply the top by x. What do you get when you multiply that? Good, x squared plus x plus, make sure you write that plus down, right? There's a plus sign in between here. Okay, what is this one missing? Nothing. So I'm just going to have minus 2. All right, I wrote that plus, and I can write minus 2. Plus and negative's fine, but it's obnoxious. Questions to that point? Stop me if you're not okay. All right, so step 4, add numerators. Any like terms put together? Nope. Step 5, restrictions. X cannot be 0 and positive 1. Step 6, factor the numerator. Does that factor? Yeah, that's going to factor. It's going to be x plus 2 and x minus 1. And then your last step, do not do it any time before. Does anything cancel? X minus 1. Don't just say negative 1. So then I have x plus 2 over x. I'm nervous. You okay? Even if you're a little rough around the edges right now, does it starting to make sense of the process? That's kind of what we're looking at. Read the steps, right? Read your paper. Now, number 10, we have a problem on number 10. Does anybody know what's causing a huge problem in this one? Forget the second fraction. I mean, that's fine. It's a minus. Why is that a problem? What happens when there's a minus in front of a whole chunk of things? All your signs change. Yeah, all your signs change. So, guys, here's my suggestion. What I've tried teaching this different ways in the past. I think the easiest way to fix this is to distribute that negative from the very start. That way it kind of goes away. I don't have to worry about it. So if I would distribute a negative, we read from left to right, correct? So it is not affecting the first fraction. It's only affecting the second. Does it affect the top or the bottom or both? If you multiply the top by a negative and the bottom by a negative, what have you just done? Two negatives make about, you just completely undid everything you just did. Okay, so we could take it to either or, right? Like if you had a fraction negative half, do you remember we had talked about I can write it on the top, I can put it on the bottom, I can stick it out in front. They all mean the same thing, but you won't put it on top and bottom because that makes a positive. So you can put it either way. My suggestion, stick it on the top. Because the bottom, if I put it through here, I'm going to have to just factor a negative 1 out of that because my first one will be negative and it's a big old pain in the butt to factor. So we will always take them to the top. So if you distribute, what happens to the negative 2x? It becomes positive 2x. And if I distribute it to the negative 1, that becomes positive 1. So what I'm doing is I'm taking that negative that's in between there, that's going to cause me issues, distribute it through the top. So really, when I'm looking at a problem, my first thing, I'm like, oh, look, there's a minus sign. Plus, change sign, change sign. That's what I'm doing. I'm changing it so that it's always a plus in between there. If not, you're going to mess up signs later. It's going to affect your whole problem. Okay? So if you see a minus, change the signs on the top of anything that's after that. No, because if you do it to top and bottom, that's like two negatives, which kind of cancels each other out. So just take it to the top. Okay, now that we got rid of those ugly signs in there, let's start. Number 1, factor denominator. Do either of those factor? Good. I can take a 2 out of here. And this one? Good. X minus 3, x minus 1. So they both factored. All right, take a minute. Don't say anything out loud. Write down what you think the common denominator is. All right, so common denominator. If I go with the mindset of it's the dessert menu and I want one of everything, please. I want to try them. That's kind of the way when I do this, that's what I do. I kind of like work my way across and make sure I got everything. So I need a 2. I need an x minus 1. I need an x minus 3. Do I need another x minus 1? No. X minus 1 showed up once here. It showed up once here. So the most it ever showed up was once in each fraction. So I only need it once. Now just let me play devil's advocate here. If this was an x minus 1 squared, I would need 2 of them then. But since it's not, there is just one. I only need 1. Okay? So it's like it showed up once here, the most it showed up was once. All right? Questions to my LCD? Go shopping, one of everything. All right, so what is this denominator missing to look like this? The x minus 3. So that means I have to multiply the top by x minus 3. How do you multiply that? The bad word? All right, so we need to distribute this. So we're going to get x squared minus 3x plus 2x minus 6. That's just the first part. I know. But stop me if you don't understand what I did. You can do it off to the side if you want. I'm lazy, so I just go right there. All right. What is this fraction missing to look like this? It's missing the 2. So that means that whole top gets multiplied by 2. What do you get then? 4x plus 2. Because it distributed, right, on the top, and had to go to both parts. Oh, we got a lot of stuff right there. All right, so then step 4 says to add my numerators. So this is where we get to put all this stuff together. So on the top, we have an x squared. I see negative 3x plus 2x, negative 1x plus 4 is a positive 3x. Negative 6 plus 2 is negative 4. That denominator is going to stay the same. All right, so I just put all my like terms together. Number 5 is restrictions. Brittany? Just 1 and 3? Good. Is there an x there? Yeah, remember, it's just like when we were solving. If there's no x there, x marks the spot, I don't really care about anything else. Step 6, factor numerator. Does that factor? Yep, x plus 4, x minus 1. Okay, so I did step 6. I factored my numerator. And then step 7, does anything cancel? The x minus 1s do. So we're left with x plus 4 on top, and 2 and x minus 3 on the bottom. That's a lot. Christina, you doing okay? All right, this is going to be the last one we do today, and then I want to give you guys lots of time so I can walk around and help you and make sure we're doing okay, all right? So right away on number 11, what do you notice? The negative. Do you see the negative in between? What should I do with it? Get rid of it. How do I get rid of it? I'm going to change it to a plus, but I can't just change it to a plus. What else do I have to do? I change everything on the top afterwards. Do I want to do top and bottom? No, because two negatives makes a positive. That cancels out. All right, so anytime you see a minus in between, the first thing you want to do is kind of like pop that negative up there and change all the signs of what's after. Yes? Yes, we read from left to right, so it only affects what's after it. Okay, step 1, factor denominators. How does the first one factor? Good. X plus 2, x plus 2. And the second one? Good. X plus 2, x minus 2. All right, again, take a minute, write down what you think the LCD is. All right, what's my LCD? How many x plus 2's do I need? I need 2. Because how many times did it show up here? Twice. It showed up twice. It has to at least be. I can't make it smaller. So I do need both of those. Do I need a third one? No. Do I need an x minus 2? Yes. Right, so as you're shopping, right? I want one of everything. I'm looking through, I'm like, I want an x plus 2 and an x plus 2. This one has 2. Since it showed up twice here, I do need 2 of them. But then I'm looking here, x plus 2, I already got one of those listed. X minus 2, I needed that one as well. Because now when I go back to step 3, multiply by what it's missing, what is this missing to look like this? X minus 2. Yes. So it means I need to multiply that top by x minus 2. And again, we're looking at a lovely distribution. Or the curse word you're not allowed to say in here. You kiss your mother with that mouth? Carson, that's totally you. Don't blame it on Dakota. All right, so we get x squared minus 2x plus 1x minus 2. What is this denominator missing to look like this? Another x plus 2. So I have to multiply the top by x plus 2. So we'll get negative 6x minus 12. Stop me if you didn't get that. Okay. You put like terms together already? That's okay. I just do it all at once. That's okay. All right, so we are at step 4. Add our numerators. So we have an x squared, negative 2x plus x minus 6x is negative 7x. Negative 2 minus 12 is negative 14 over that common denominator. How else could you write that common denominator? Yeah, you could write x plus 2 squared if you need to. Okay, step 5, restrictions. Good, plus or minus 2, coming from my denominator. Step 6, can you factor that numerator? No, it's not going to factor. So does anything cancel? Nope. This is where students get frustrated. They're like, I must have done something wrong because it didn't factor. Was that what you were complaining about? You're like, I messed up somewhere. It happens, okay? And I know right now on your test for this chapter, there's problems on there that don't factor. And kids will spend forever trying to get them to factor. They don't always.